Hello, we're going to be looking at permutations in this video. Specifically, we're going to be asking the question, how do we know when we have to use separate cases when we're calculating a permutation? I'm going to do this by showing you three different examples. The first two examples do not require cases, and the third one does. So we'll see if we can see what the difference was in the questions. So example 1, using any of the digits from 1 to 9 without repetition, how many 4-digit numbers can be formed if the first digit must be odd and the last digit must be even? This is a fairly classic permutation question. I'm going to use the fundamental counting principle. I'm going to have 4 decisions to make, meaning which 4 digits do I want in my 4-digit number. And I have 2 restrictions. I have a restriction in the first position and I have a restriction in the last position. I'm going to list my allowable values under each restriction because this is going to help me know when to split this into cases or not. So the first digit must be odd. So looking at the numbers 1 to 9, I could use 1, 3, 5, 7, or 9 in the first position. In the last position, the last digit must be even. So I could use 2, 4, 6, or 8 in the last position. You'll notice there is no overlap in the lists of allowable values under each restriction. And we'll see this in the third example, but that is how you know if you have to split into cases, is if you have some overlap in these lists. So I can just straightforward go ahead with this question. I have 5 choices for my first restricted spot. I have 4 choices for my next restricted spot. Now the digits 1 through 9, there's 9 digits there. You can see all 9 of them down here. We used 1 here. We used 1 here. So from 9 digits, I've got 8 left and 7 left. So I've got 7 choices here and then 6 choices here. And you would multiply all those together to get your total count. Your total count would be 840 different 4-digit numbers. Okay, let's move on to a similar example. Again, using any of the digits from 1 to 9, so we have 9 digits to choose from, without repetition, how many 4-digit numbers can be formed if the first digit must be even and the last digit must be even? We're going to have a very similar setup to last time. We have 4 digits, 4 decisions to make, restriction in the first position and restriction in the last position. In the first position, I have to have an even number, so I can put either a 2 or a 4 or a 6 or an 8. In the last position, it also has to be even, so I can put 2 or 4 or 6 or 8. These restriction lists are exactly the same. That's fine as well. That does not mean we have to split into cases. This works just fine. Start on either restriction. We're going to pick one of these 4 numbers from here, so I have 4 choices. Now let's just say for argument's sake I had chosen the 8. When I come to this restriction, the 8's gone. So I have 3 choices back here. And then from 9, for my middle 2, I can pick anything I want. So from 9 digits, 1's gone there, that's 8, 1's gone there, that's 7, so I have 7 left, and then 6 left. And again, you just multiply those all together to get your total count of 504 different 4-digit numbers. It's this last example that's going to cause us some problems. Using any of the digits from 1 to 9 without repetition, how many 4-digit numbers can be formed if the first digit must be greater than 5 and the last digit must be even? On the surface, this looks like a very similar question to the last two. And it is in the sense that you have 4 decisions to make. You have 2 restricted positions. I'm going to list what I'm allowed to put in each restricted position. In the first position, I have to have a digit greater than 5. So I'm allowed to put 6, 7, 8, or 9. Notice I'm not counting 5, because 5 is not greater than 5. The last digit must be even, so in the last digit I'm allowed to put 2 or 4 or 6 or 8. Here's where the problem is. You'll notice in these restriction lists they're not exactly the same, but they do share a couple of elements. This is where you have to split this question into cases. The reason you have to split it into cases is you won't be able to know how many choices you have for your second restriction because you won't know what you picked for your first restriction. Let me give you an example. Let's say we were actually going to put a 7 here. We have 4 choices. Let's say I actually put the 7. If I do that, I'm going to have 4 more choices in the back because I could put 2, 4, 6, or 8. Those are all available. But if I put one of the underlined numbers, let's say in this 4 choices I had chosen my 6. When I come back here, the 6 is gone and I only have 3 choices. But the whole crux of this is you don't know what you're choosing. You're just listing a number of choices. So it's impossible to know which one we actually picked here. And that's why you have to split into cases. The cases will revolve around these numbers that occur in both restrictions lists. And again, to be completely clear, if both restriction lists are exactly the same, that's okay. It's when you have some elements that are the same and some that are different, you have to split into cases. So I'm going to switch to the next slide, and I'm going to show you the cases. So in case 1, I'm going to say the first digit is 6 or 8. You'll remember from the last slide, those are my 2 problem values, right? If I had 3 problem values, I'd list them all here. If I had 5 problem values, I would list them all here. Okay. So in my first position, I'm only allowed to choose a 6 or an 8. In my last position, I'm only allowed to choose an even number, so 2 or 4 or 6 or 8. So here I have 2 choices. Now, no matter which one of these I choose, one of them's gone from here. That gives me 3 choices in the back. And then, like the other examples, we've got 7 and 6 in the middle, giving me 2 times 7 times 6 times 3 is 252 different 4-digit numbers where the first digit is 6 or 8. In case 2, I'm going to use my non-problem values. So I'm going to say the first digit is, and let's go back and take a look. 6 or 8 were my problem values. 7 and 9 were not problem values. So first digit is 7 or 9. So again, 4 underlines. Restriction in the first spot, restriction in the second spot. Our restriction in the first spot is we can only use 7 or 9. In the last spot, we can use 2 or 4 or 6 or 8. So I'm going to start with my first spot again. I've got 2 choices. Now again, regardless of whether I pick the 7 or the 9, that doesn't change these choices over here. So I still have 4 choices for the back, and again you can see the 3 in the back and the 4 in the back. That's what caused us to have to change into cases. And then we still have 7 and 6 in the middle. So 2 times 7 times 6 times 4 is 336. And in a question with cases, once you've got the count for each case, you simply add the case counts together. So 336 plus 252, and we have 588 total numbers. This was a quick look, but I hope it sheds a little bit of light onto when you need to split into cases and when you do not. Thanks for watching.